my name is Anna Benzel. Welcome back to my channel. We are here on a bright, shiny, happy Saturday morning. No complaints. I just took my neighbor's dog for a walk. I'm about to try to power through as many of these as I can. And I'm about to drink my caffeine. So bear with me as we go through these LeetCode problems here today, starting with 80. Remove duplicates from sorted array 2. Okay, so we've done the first one. Now we need to do this one. So let's jump into this Python solution. Today's video is in Python. So let's read this question. Given an integer array nums sorted in non-decreasing order, remove some duplicates in place such that each, let me start the timer, such that each unique element appears at most twice. The relative order of the elements should be kept the same. Since it is possible to change the length of the array in some languages, you must have the result be placed in the first part of the array nums. More formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. That could have been really bad. It does not matter what you leave beyond the first k elements. Return k after placing the final result in the first k slot of nums. Do not allocate extra space for another array. Oh my god. You must do this by modifying the input array in place with O1 extra memory. Custom judge. This judge will test your solution on the following code. Okay. I should have read this one beforehand. If all assertions pass, then your solution will be accepted. And we have our examples. Nums 1, 1, 1, 2, 2, 3. 1, 1, 2, 2, 3, blank. Okay. Your function should return k5 with the first 5 elements of nums being 1, 1, 2, 2, and 3. So 0, 0, 1, 1, 1, 1, 2, 3, 3. Okay. The first 7 elements of num being 0, 0, 1, 1, 2, 3, 3. It doesn't matter what you leave beyond the returned k, hence they are underscores. Okay. Nums sorted in non-decreasing order. I feel like I need to read through this one more time. My brain was not ready for this. Okay, so basically, the spark notes of this, if I'm deducing this correctly, we need to iterate through the nums while keeping track of the count of the current element, and then remove those elements that occur more than twice and move those valid elements towards the beginning. Okay. I mean, when I summarize it like that, it makes more sense. Let's read through this one more time. Now that I'm on 2 sips of caffeine. I know it doesn't take effect that quickly. I'm just pretending it does. I'm tricking my brain. Okay, so given an integer array nums sorted in non-decreasing order, remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements should be kept the same. Since it is possible to change the length of the array in some languages, you must instead have the result be placed in the first part of the array nums. More formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. It does not matter what you leave beyond the first k elements. Return k after placing the final result in the first k slot of nums. Do not allocate extra spots for another array. You must do this by modifying the input array in place with O1 extra memory. Okay. So I think my SparkNotes version was correct of this. So removing duplicates shouldn't be that hard. But I'm saying that now, and I don't entirely know where to start. I know where to start. I want to start with a base case. So we know nums And if there's nothing there, then we just return 0. So if not nums, return 0. And then for k, I think we should initialize k to 1 because the length of the first element always appears in the result. And then we also need to initialize the count for 1 to count the occurrences of the first element. So let's say k is 1, count is 1. So we initialize those two. I feel like that's a good place to start. So what I think we should do then is do a for if else. So we need to iterate through the nums array starting from the second element, which in this case is going to be the index 1. So that would be like the length of nums. So we're going to say for I in range 1 and then the length of nums. So we need to check if the current element or the previous element is the same as the current. And if it is the same, then we increment the count. Yeah. So if nums I is equal to nums I minus 1, then we count the increment, else we decrement. And then, because it can only be duplicate, so if the count is less than or equal to 2, then k, then we need to copy the k if position and increment the k. So if count is less than or equal to 2, because that's our duplicate, and then we will do this with k. And then we just return k, right? So we got our base case. We initialized k to the result length of 1. We initialized the count to the first element to 1. Then we break this down into iterating through the elements and checking to see if this is the same length of the previous element, and then we check to see if there was more than 2. If the count exceeds 2, then we don't include the element. So then this would be the modified array result. Let's read through this one more time because I just want to make sure I didn't miss anything. But to me, this would make the most direct sense. So given integer array num sorted in non-decreasing order. Remove some duplicates in place such that each unique element appears at most twice. Right. Okay. Okay. Return k after placing the final result. Do not allocate extra space. We didn't allocate any extra space. And this would modify that input array in place. Now, sorted in. Okay. These are, I mean, yeah. Let's run it and see if we got something here. Where is that? Line 20. Name num. Oh. It's the lack of caffeine for me. Wrong answer. So let's see. Expected 2, 2. Okay. So we're booting something out where it doesn't need to be booted. So, oh, I guess I am decrementing it here. So let's make that equal to 1. And then I think this math is right, unless no, because we need that there. Let's run that. Let's try it with just equal to 1. Yeah, that's what I'm talking about. That's what I'm talking about. Okay. So it definitely takes account for these cases. I think that's going to be fine. Let's go ahead and submit this bad boy. Okay. Oh, over 50% on both runtime and memory. That's all I'm trying to do. That's all we're trying to do here. Barely skating by though. Okay, so looks like that was a decent solution. That felt like a very elementary solution to that problem. That also, I don't know why that was medium. I think maybe just like the lengthiness of the question. But yeah, I feel pretty good about that. So I will put this in my GitHub repo. That took us, about 10, 11 minutes in total. So that was pretty straightforward, I think. I was just more second guessing myself that I was reading all of this correctly, because I did flub up the first part. So yeah, anyway, this is going to be in my GitHub repo link, which is down in the video description down below. You guys are more than welcome to fork and clone, make it better, make it worse, have some fun, learn something new, and I will see you guys in the next video. Thank you so much for watching. Goodbye.